Hello all. Today I'm gonna work on this very simple project, which is to run a school of fish on top of a geometry you choose. So it's like a swarm intelligence stuff that I did before, but more like a swarm on the surface, on the specific surface, which you could make it pretty easily, so I'll explain how you can do that. So I'm gonna start by creating a geometry node. And first of all, I need some geometry which a fish could swim on. So let's make some random geometries, such as torus, maybe a sphere, or maybe a rubber toy from an example. Right, and let's set the size of each geometry about the same size. And let's also make these polygons. I guess this is okay. And this one, maybe I should make it a little bit bigger. Okay, that looks good. Now I will use the switch so that I can change geometry later. Like this. Okay. Now let's also make a null to have all the controlling parameters, which in this case is the switch index. So I'll just call it switch from 0 to 2 in this case, because we have 3 geometries. And I'll paste this to here. Okay. Now, first thing I would like to do is to delete the faces of this geometries, or maybe I could just plot some points on top of this surface. So I'll use a scatter, and this will be the number of fishes which you want to run on top of the surface. And right now it's 1000. Maybe I should make another parameters so that I can control the number of it. So num fish from 0 to 1000 maybe, or maybe more, to 10,000. And let's copy this to force total count of scatter. Okay. Now I can control the number of fishes here. Maybe I shouldn't do too much. I shouldn't make it too much. Right. And now I can change the geometry by switching it. Let's change the background to dark so that I can see a bit more clearly. Okay, now next I will make a solver so that each frame the position of the fish will be updated by the previous frames. And what I want to do in order to make a swarm on top of the surface, I don't want each fish to like collide each other. So that's what I'm gonna do now. And since this is gonna be more like an organic movement, I'm gonna use some random functions like noise in this case. So I'll use the point wrangle here to make some random movement initial random movement based on the point position and the frames. So I'll connect this here. So this one is the point that you see on here on the viewport. And on the point wrangle, I'm gonna call it random walk. And let's see. First of all, I would like to make a noise from the point position. So let's make a noise using, maybe I'll call this direction deer, and use the noise based on the point position plus maybe a frame. Right, and I should also subtract this by 0.5 for x, y, and z, because the range of the noise is around 0 to 1.0. So by subtracting by 0.5 for x, y, and z, you can create a random direction to go any direction, which could go any direction. If you just use this without the subtractions, then it just go to the positive axis direction. So this is why I did this. Now next I would like to multiply, first of all let's normalize this direction. Or maybe not. Maybe I could just use this as it is and maybe multiply this direction using some speed parameters. So I'll make a speed parameter here. Right. And also maybe I could also create some scale function for the noise. So I'll call this scale here, scale parameters. Maybe I'll start with 0.5 or something. Okay. Now after I have created the direction, maybe I could update the current position using the direction I have just made. Alright, now let's check if it's going okay. Let's see if I play it. Yeah, it does move. But as you can see, currently the point is not on the surface, it's just go outside and start to twist. Okay, now let's make some parameters for the noise scale. Let's call this smoothness. And speed. Okay. And let's copy this parameters to the parameter that we made. First of all here, this is for the smoothness and this is for the speed. I'll just replace this with speed. Alright. Now let's go back a little bit. And okay, seems like I guess this range could be 0 to 1 for both. What about maybe a little bit more for the smoothness, maybe till 5, 0 to 5. Let's try. Yeah, interesting. Now, next thing I have to do inside the solver is to project those points, all those points onto the surface so that it doesn't go outside. Now, in order to do that, the easiest way that I could do is to use the ray node. And I'll use the project method as a minimum distance, and in order to use this I also need to set the geometry, the base surface, like these, into the second input, and which is this one, so connect it here. Now I don't see anything. Is it connected? Yeah, it's connected. Okay, let's go back and see it again. Okay, now it is on the surface. Now the next problem is that each point as the frame goes on, the points got too close to each other and just stops at some point. So, in order to avoid this, I think I need to add one more stuff in order to avoid this. So, which is I could use point relax for this purpose. So what I want to do is to just separate each points at some distance, so the relax could use it, do the job. Alright, now I could set up some strength for the relaxing using this parameter, max iterations. I'll just set it to 5, and let's go back and see how it goes. Now it looks as what I wanted. Yeah, it does looks like what I wanted. Now, as you can see, if you just show it as a point, you can't really figure out if it's moving like a fish or not. So let's also show some trail after the solver, like this, and let's also make some parameters for this one, this trail as well, so that I can control the length of the fish, and yeah, just the length of the fish. So, which you can control here, trail length, which is number of points to use it as a trail. So, which is integer here, so let's make a parameter for that. I'll just call it length, which is from 0 to 10 is fine, I think. Let's copy this, paste it here. Right, and let's go back and play it again. Yeah, looks interesting. Now I want to have these points as a polyline now. So what I could do, I think I could do it from this trail, isn't it? Let's see, connect as polygon and check, uncheck close rows. Yeah, which will make a polyline like this. Now it seems a bit it's not that smooth, so let's connect some resamples to smooth out. First of all, I have to set some, maybe I could just use the maximum segment around 8 or 10, maybe 10, and also use the subdivision curve, which should make it smooth. Right? Looks good. Now, after this, using just line cannot be rendered, so let's also use some poly wires to thicken this curve. Now let's set some radius to 0.01. Maybe in order to show the direction of the fish, which is going from to, in order to show the direction where fish swims, I could use, from resample, I could promote this curve U parameter, which is used to, which will create a float attribute for each curve, which the start point will be 0 and the end point will be 1, so, and gradually changes by the position of the point. So by using that, I could control the tail and the head of the fish using this attribute. So let's call that OP input, and the name of the attribute is curve U at PT. Wait, maybe I made a mistake. Okay, this should be PT and just the first variable. Okay, now let's check. Yup, looks more like a fish. Alright, now maybe I could also parameterize this value so to control the thickness of the fish. Right, so let's give a float parameter here from 0 to maybe 0.1. Copy this, paste it here. Right. Okay, now I could also put some colors for this based on the curve U again. So ramp from attribute, curve U, and the black will be tail, I guess. Oh yeah. So I'm gonna set the tail color to blue and the head color to yellow, orange, green, doesn't matter. Okay, a bit ugly. Light blue, yeah. Okay, and maybe I could also reduce the size of the head as well. Alright, and let's hide the wires, and actually this is it. This is pretty simple for what I make usually, but the result is pretty much satisfying. So pretty easily you could create a school of fish which swims on top of the surface like this, and you can control the number of fishes by changing the parameters here, and you can also control the smoothness, how each fish moves based on the neighbors. If you lower this, the fishes tries to move on the same direction based on these positions, their positions and speed. You can set how fast the fish moves. And let's reduce the number of fishes here so that I can make smooth animations. Alright, and if I wanna make the fish longer, then I can increase the length. Thickness will control the size of the fish, and that's pretty much it. I hope you liked it. I think anybody could use it. I didn't use much Vex here this time, so it's pretty easy for everyone, I think. Try it out yourself. Okay, thank you. I forgot to show one thing. If I change the geometry, so if I change to the sphere, okay, this is not sphere. Wait, doesn't change. I think I should clear the cache. Alright. So this is for sphere. If I change to another geometry, like a rubber toy, let's go back. Clear the simulations and run again. And like this. Yeah. So this could work on any kind of geometries. Well, this is a bit noisy here, glitchy here. But basically it runs, the rule is pretty simple, so pretty works on any kind of geometries. You could try it out yourself. Okay, thank you. Okay, I'm sorry, one more thing. I made a mistake on the Vex script, so please fix that one. Before I wrote this here in a different way, like this, but this doesn't work on Vex. You have to type in like at frame and some multiplier here. So replace those $FF with this line and it should work just fine. So if I run it, each frame, the position of the fish will just moves, the direction will just change gradually based on the frames. So if you also change the multiplier's value, the speed of the change could also be controlled. So try that by yourself. Okay, that's it.